So let's begin. A very good afternoon to one and all present in this meeting room for the second session of day 6 of our faculty development program. This is an AICTE sponsored 2-week faculty development program, which is being organized by Ballarpur Institute of Technology, Ballarpur. And our honorable guest for this session, Mr. Rohan Dange sir, is already with us. He has already joined us. Thank you very much, sir, for joining us. And I would now take this opportunity to introduce our honorable guest. So Rohan Dange sir, Mr. Rohan Dange sir has around 10 years of experience in development, predominantly in manufacturing domain. He has worked in different organizations like PwC, KPMG, Kirloskar, Bright Water Solutions, and Tech Mahindra before joining Tata Elxsi. In Tata Elxsi, he is working as regional manager for Asia Pacific region, where he is responsible for business development in areas like rail, automotive, media and communication, and healthcare technology. So we can see that he has a vast exposure to a varied domain. During his tenure with Tech Mahindra, he was doing international sales, and extensively he has traveled to various geographies like South America, Middle East, UK, and ANZ region. He has done MBA from Symbiosis International University and engineering from Nagpur University. In free time, he likes to read newspaper, watch football, and drive. He intends to continue his education in energy and environment domain. I am really glad, Rohan sir, that you have joined us here in today's meeting. And I now request you to please start addressing the session.
Thanks, Vijit sir, for the introduction, and good afternoon, all. It is indeed my pleasure to have interaction with the present dignitaries and the faculty members of the institution. And whatever limited experience I have in this domain, still say limited experience because I am still 10 years in the industry, and I say around 1/3 I have completed, so I will use that word limited. And yeah, so I'll use my limited experience to just give or share my understanding in these two areas, that is engineering education in practice and creative thinking. And my reason choosing these 2 points is that since I work for Tata Elxsi, and the tagline of our company is engineering creativity, so it is a no-brainer that these 2 topics are very close to me, whether it is for my professional work or my personal ambitions. So with this background, I would like to start today's presentation. So first of all, with whatever 6 companies I have worked with, and with the general observation in the industry, these are the employers' perceptions in today's engineering graduates. First is technical arrogance. I mean, engineering graduates, when they graduate out of the engineering schools, they generally have this I know all kind of an attitude. As far as understanding of manufacturing processes is concerned, I think since they have not worked on the ground, there is no there is a very limited exposure to the manufacturing processes. Last but not the least, since design engineering being not a part of this curriculum, they lack those design capabilities or creativity. And yeah, I mean, from the word go, they all want to be managers. I understand that, yeah, after 8 to 10 years in the industry, people get that position. But in today's generation, they are fast-paced world. They all want to be managers in the first go. And well, I don't want to be very in this criticism mode, because I myself have been a part of this process, and so it's obvious. I mean, it's nothing to pinpoint certain students, but this is a very general view in today's world. And definitely, I can definitely scale in terms of communication skills. Generally, they are weak, and there is a lot of overhauling that is required. And yeah, and they have very limited experience in working in teams. So these have been general observation, and I think these areas the today's engineering students need to work upon if they want to be employable. So what is the way forward? I mean, I don't believe in just discussing problems, but I believe in giving solutions to the problem. Yeah, so I think one of these 4 or 5 points are very important. Wherein they should be involved in project-based learning. They should have a very holistic view of mathematical and scientific concepts in the context of application. What today industry needs is domain experts. I mean, now I'm working in manufacturing domain. So since I have consistently working in only this domain, I'm in a much better position to talk about the problems of manufacturing domain. And what today we are seeing is, one size fit all approach in the industry, wherein people, are not getting the domain expertise from the individuals. So I think, domain specific requirements are very important in today's world. And that would, how that would come, that would definitely come through close interaction with the industry. Of course, broad use of information technology in this world of 4G and now soon to be 5G. I think everyone under the sun have access to technology, and I think we should make good use of technology in the education world. And of course, again, nothing to pinpoint to certain people. I think on the faculty side, I think they need to be more involved with the students, and wear that cap of being mentors and coaches. And I think if we implement these things, I think the scenario would change in the upcoming years. And I'm pretty confident that the change is going to happen. And last but not the least, this curriculum upgradation. Honestly speaking, when even I work in electrical vehicles domain, automotive engineering, industry 4.0. Trust me, whatever I have learned way back in 2011 when I passed out of my engineering, hardly, trust me, even that is also hyperbole. Only 5% of my knowledge I would be actually using in my professional career. So then again, people would debate that whether the education system was not robust or I was a bad student. Well, I am ready to take that blame on me that I was a bad student, but still, I feel that even if we talk of generic terms, people, the overall curriculum is not up to the mark, and it's high time that we bring the required upgradation in the curriculum so that the industry and academics are in hand in glove moving ahead. So I think development of appropriate computer skills are is important. No more development the language like C, C++ can only be considered as the appropriate computer skills. With now big data analytics coming into the picture and host of other technologies which I will discuss in the subsequent slides. I think there is much more to explore on the computer skills side. Of course, written and oral communication skills I have discussed. Another important part is when a typical techie or engineer would only think of a technology aspect while developing a particular solution. But then as a techie, they don't consider the social, economic, safety, legal, environmental aspects of a product. Because since I myself work in a product development industry, typically what I find is there are engineers who are working for product development. They only think of technology, but that is not going to solve the purpose. They should have a complete 360 view while developing a product. So I think that is another area where curriculum upgradation needs to look into. And of course, application of probability and statistics to the engineering problems, and very important, hands-on laboratory experience in basic science and engineering courses. So I think even if people are going for this winter internships and all, I think the seriousness is not to the required level, and that's the whole reason these laboratory experiences and hands-on trainings are required. So with this background, I come to the point of next-gen engineering opportunities. You consider any engineering stream, mechanical, electrical, IT, and other engineering streams. Generally being in the industry for 10 years, I found out that these are the main areas where the next generation of engineering opportunities will come. Basically, the big data, the cloud computing, the system integrations, augmented reality, simulations, and Internet of Things. Now, if you talk of big four IT companies, Infosys, TCS, Tech Mahindra, HCL, Wipro, these are all, nothing but system integrators. And what other companies, next gen companies, if I talk about, they are, their revenues coming from the digital solutions, and these digital solutions are nothing but big data, cloud computing, simulations, IoT. And recently Infosys published their quarter 2 results, and I was not surprised to see that 50%, around 50% of their revenue is coming from the engineering solutions that have been showcased in this slide. And why these solutions are important? Because they enhance the productivity of clients, machine efficiency, process optimization, and optimum resource utilization. On the other hand, what is really reduces is the its production cost, the resource wastage, rework efforts, and the machine downtime. So yeah, so I think these are the areas which can be or should be the focused areas for any engineering streams if they are really looking for a very good career in the coming say 2 3 years. I think this would be the skills that would be very much in demand in the market. And meantime, if anyone have any queries, feel free to interrupt in between. Now, since I now predominantly work in the automotive domain, and have been working for a lot of OEMs like Tata Motors and Maruti Suzuki, Mahindra and Mahindras, and other companies based out of Asia Pacific region, Alstom, Bombardier in the rail domain. So I just want to discuss the key trends that is coming in the automotive domain. Because see, these trends, even if they are relevant to automotive, somewhere they have connection in other industries as well. So these are like human machine interface, system engineering, telematics, intelligent vehicle system, digital simulations and research, embedded systems development. And trust me, all the companies across the globe will have their global capability centers, that is GCCs, based out of India, because they want to work on a LCC model, that is a low cost country model. And when these people work out of India, they have, first of all, the talent is abundant in India. So that's the whole reason they want to work out of India. The second thing is, the kind of per hour
Sir,
rate.
sir, you said that we are free to interrupt, right?
Yeah.
You said that talent is abundant in India.
Yeah.
So that is something that if you will please elaborate, because you see the perception for us on like in the education industry, what we feel is there is a huge gap between the education, the way we are imparting education and what is required in the industry, and we wish to bridge that gap. That is one thing. Apart from
Correct.
that, there is another perception that in other countries there is not such a, the gap is not that huge. So when you say that talent is in abundance in India, what do you actually refer to?
Yeah. So actually, what I mean to say is, the talent is there, the potential is there, but way we train these, talents, with the way we nurture, the way we teach to them, I think there we need a course correction. And if we are able to do that, then definitely we would be able to produce employable and highly industry ready individuals. So I'll say a proper guidance is required to these folks. But as far as potential is concerned, I have absolutely no doubt that India as a country, we have a very good set of potential candidates who have a very good technology acumen. As far as second thing is concerned about other countries, so other countries, whatever my experience says is other way around. They have a very, I'll not say limited potential, but I think they are being trained properly. That's the whole reason their employability index is higher as compared to Indian counterparts. So, and another thing, as far as the cost per hour or the overall salary index and all is concerned, since in other countries the population, except China, the population is not a problem. So people with right talent are able to get right set of salaries as per their acumen. But in India, due to large amount of competition and the other factors, the talent, first of all, is not nurtured properly, and second thing is that due to competition, since the availability is there, the salary range is not as higher as to their as in other countries. just to apply economics, the demand is lower or medium, but the supply is more. That is the whole reason the overall cost is low. So, if we apply this economics model to India, that is a very apt. And yeah, so that's my explanation over the question. I hope it has resolved the query.
Yes, yes, sir, very much.
Yeah. So I think so. If I the key areas, if I have to broadly distribute into three buckets, the trends would be electrification, connectivity, and autonomous in automotive world. And that is the whole reason the trend of electric vehicles is catching up in the entire world, and India is no more a laggard. We have seen the companies like Tata Motors coming out with electric vehicles like Nexon EV, and trust me, working in this area, every other OEM in the market is going to come out with a electric vehicle model. Every OEM by 2025. So I think this is one of the key area where I think there is lies a lot of potential. So that's the whole reason I have picked up this electric and vehicle engineering. Definitely coming from a very techno-commercial background, I would like to give a very high-level sense of people say, oh, there is a lot of potential in electric vehicles. Electric vehicles are going to be the next thing in engineering. But I am not very sure that within the faculty, within the students, they really understand that what are the finer components in electric engineering, wherein these engineering services or the tier ones or the OEMs are working in which areas. So basically in electric vehicles, these are the main areas. I'll just read it out. So battery management systems. So batteries is the key or the heart of any electric vehicle. So how a battery management system is designed so as to ensure that vehicle is able to cover a proper range of say 300 kilometers without any default. So this battery management systems, then of course charge control modules, because charging is a very important function in electric vehicles as is in our mobile phones. Then electric vehicle control module, if there is any problem in the vehicle, then now there are diagnostics mechanism which would come. The mechanism are so integrated with the smartphone that they will themselves tell that okay, this component of the electric vehicle might fail in another 100 kilometers or has failed. So the diagnostics level have gone to another level. No more is a case that you have to go to a mechanic and ask for his intervention as to tell me what has gone wrong in my vehicle. No more is the case. With the connectivity and the advanced technology, the car would go in a self-diagnostics mode and tell the driver what has gone wrong in the vehicle. Then DC-DC converters, because the various electrical systems in an electric vehicle would work at different voltages. So those internal converters would play an important role, and the engineering behind those converters is very important and a very niche area where people would be required from the engineering background. Then of course the onboard chargers and the range extenders. So these are the typical areas where lies a tremendous potential. And company like ours, Tata Elxsi, we deploy electrical and mechanical engineers in this domain to our end customers in the automotive domain. And we are seeing a lot of demand for such engineers. I myself have got approval to hire 300 engineers for electric vehicle domain. So you see this COVID-19 situation, this electrical vehicle domain is foolproof. When people are talking about layoffs, our company is thinking of hiring 300 people for electric vehicle domain. So such is the potential of this area. So anyone have any doubt on this? Because trust me, this is a very interesting area, and all the next level of engineering would be in this domain. And
if any of the members who are attending the session, if you have any queries, you can unmute yourself and feel free to ask to the resource person, please. You can also write your queries in the chat box. If you are not comfortable asking them directly, I will read them.
Yes. I think, or maybe you can, just note down your queries. Once the session is over, maybe we can try to finish it around 15 minutes before the time. And maybe the last 15 minutes we can keep for Q&A session. because with the lot of information getting thrown up, I am sure that as we eventually move on, people would get some queries. So maybe if last 15 minutes we can keep for Q&A session.
Certainly, sir. I have one query over here.
Sure.
That is, you have mentioned so many systems over here: battery management system, charge control modules, and
Yeah.
all these things. Now, when we talk about all these areas, do we mean that they are all of these areas? They have like a person has to have a special expertise. Like each of these areas, are there profile into which a person is working, or is there one person working for several things?
Definitely, I mean, at the starting, no more domain expertise is required. Or a embedded engineer or a electronics engineer who have a good knowledge of embedded technology is very well capable to work on all these areas in one go. A very good electrical and electronics engineer. So, but certainly, as he moves on into his career, definitely after say 5 years he has to choose a domain of expertise, because say battery management system for a say high level engineering, you don't require a very deep dive of the battery management engineering concepts. But definitely for on vehicle implementation, or to solve the problems which are on the vehicle when these are implemented on vehicles, so after a certain level the expertise and domain knowledge is required. So yeah, then that person can go a deep dive and do some specialized courses in battery management system, or can take some trainings, and those trainings are provided in the organizations. So yeah, definitely, so it can a good electronics or electrical engineering having a profound knowledge on embedded systems can work on all the areas. That should not be any problem.
Thank you, sir. That answers my
Yeah,
question.
yeah. Now I'll do some little deep dive into the overall process or product development in electrical vehicles. So basically, because see, definitely when we are developing electric vehicle, it is nothing but a product development. It is in management jargon, it is nothing but a PDM for me. That is a product development management. So as a as a management enthusiast, I would always like to break that into the PDM cycle. So in typical electric vehicle and hybrid electric vehicle, the first stage would be the specification and requirement definition. So it typically involves understanding of subsystems, functionalities, and the behavior of electric vehicles. What it precisely means is that which vehicle you want to develop, whether it's a two-wheeler, three-wheeler, four-wheeler, or a commercial truck, whether it would be a complete pure electric vehicle or it would be a hybrid platform. So that is a requirement document that is prepared. Second thing is architecture of the vehicle. So yeah, architecture of the vehicle would be in vehicle also. I mean, now vehicle is no more a mechanical commodity, but it is more of a I'll say a digital commodity. It has digital aspect, it has mechanical, electronics, IT, hardware, everything into it. So the second thing is would be which microprocessor I want to have. If I talk of battery pack, which battery pack, what are the finer details of the battery pack. If I talk of software and the communication protocols in the vehicle, which software protocols I would like to go for. So there are you understand there are a lot of things that goes into the architecture definition. Then the algorithm development. So algorithm development is nothing but your software development, wherein you want to see, okay, I mean, which kind of software I want to develop, whether it would be an internal development, or if I want to get it done from some engineering services provider, or if my company mandates that I should have some standard software definition which I should adhere to. There are then some industry standards which are mandated in certain geographies. So if Tata Motors is producing in India, they would not have certain they would have to adhere to certain rules and regulation. But when they have to produce the same vehicle in Europe, then the European market would have their own set of rules and regulation regarding the software architecture. So adherence to those things are taken into consideration. Then comes the testing and validation. So testing and validation is just to see whether are there any issues in my codes. Suppose if I designed a vehicle to run for 300 kilometers, then I have to test and validate whether really my vehicle is working, is able to travel 300 kilometers in different weather condition, whether it is rain, whether I am traveling in a very sunny condition. In all the condition, it should be able to, travel 300 kilometers. Then vehicle integration and validation. Then lot of these software components are only tested and designed in lab, but actual issues comes into the picture when these softwares are ported onto the vehicle. And then field data collection and analysis. So if I say vibration analysis, so how my vibration data or how my vehicle is performing in cement roads or rural roads. So all this field data is collected and analysis is given. So understand this product development is not a 1 year or 2 year cycle. The vehicle which Tata Motors is planning to launch in 2025, trust me, the architecture stage have already been started by our company in 2020. So imagine the vehicle programs which are scheduled for 2025 and the specifications were freezed in 2019. So this product development for automotive industries for typical 6 years. And I'm pretty sure a mechanical or a electrical engineer sitting in a classroom would have no idea regarding all these things, back planning and field data collection analysis and all that. So I think here the industry interface, here the winter internships, here having a collaboration with the industry is important, so that the student gets exposure to these things. They know, they might be knowing about vehicle engineering, but I'm 100% sure that they don't know about product development management. So I think this is a good way wherein engineering meets kind of a management. So this is the need of the hour. I'm not again saying that people should go for MBA programs post their engineering. I'm not saying that. All I'm saying that some of the management concepts need to be taught to the students in the final year, so that they understand the business side of it also, not only the technology side, because the technology side will not help you sell the product to the end customer and would not enhance the user experience. The user experience, here comes the driver experience, which I'm talking about. Another area which is flooding like anything and flourishing like anything is big data analytics and machine learning, wherein if I would drill down, it would be predictive data analytics. So imagine my car or my critical equipments in the industry, they are giving out important data on a continuous basis. And then I have a machine learning software which analyzes the data and say from the vibration data analysis, it is able to tell me that in the next 24 hours, if I don't do any maintenance on a particular machine, it will break down, and breakdown would lead to production halt. Production halt will lead to monetary losses. So in this way, you understand now there are many smart algorithms that are there in the machine learning and artificial intelligence, which are helping industries to work efficiently and helping in coming up with predictive maintenance. So predictive maintenance is before anything breaks down, the module or the software is able to predict. And I think there are so many tools in this big data analytics and machine learning domain. And since this big data analytics and machine is across industry, you talk of healthcare, you talk of energy utilities, you talk of telecom, you talk of banking and financial services, all would have a very good use cases in big data analytics. And I myself, I'll tell you a very on the ground problem, because since I always boast about having on ground experience. Basically, there were pump sets by Kirloskar, which were installed on Maharashtra-Karnataka border, and those pumps, there was some problem in those pumps, and because of which the water supply to the nearby rural areas got affected. So we were called by the Gram Panchayat to look into the problem of the water, because water is a very critical very critical in agriculture, application. So we went there. And we analyzed the different parameters of the pumps, the vibration, the energy consumption, the flow, and then we found out that there are some problem in the pump, and it needs a overhauling. because certain components have malfunctioned or their life have gone. They are because they were installed 15 years back. So we did all the overhauling in those pumps, and we were about to leave the premises. And then all these people from 2, 3 villages, they came to us. Predominantly, these were farmers. That okay, you have solved the problem now, but what is the guarantee that after another 1 year or 2 years, the problem will not come? We need to have certain mechanism because our agriculture and of course our bread and butter depends upon water and pump. So you coming here solving problem once doesn't serve our purpose. So you give us some problem, some permanent solution, and ensure that the help is just a call away and it is resolved within 24 hours. Because it took 15 days to solve the problem, and we cannot afford to lose 15 days. So then at that time, I contacted various big data analytics, cloud computing professionals, and that was the first time Kirloskar company, which is into mechanical pumps, actually got into these offerings. Then we implemented the sensors on the pumps. All the pump data was saved into cloud, and the data was taken from the cloud on a hourly basis by the by computer located remotely in the gram panchayat offices, and that data was continuously analyzed remotely by our engineer sitting in Pune office. And we were able to predict from the data that was coming that the pump is working properly. And then there were certain alarms that we have put, that when there was some problems or very some anomalous behavior in the data, we could predict that okay, that ball bearing temperature is going above the critical limit, so that pump might default in the coming 7 days. And in this way, the predictive maintenance was implemented using these smart solutions on data analytics. And post that, people were very happy with us. We never, after that, it never happened that we need to go to that remote location and solve any problem. Sitting in Pune office, we were able to monitor the pumps that were installed in Maharashtra Karnataka border. So that is the power, that is the impact, that is the main takeaway of this big data analytics and machine learning. And I'm pretty sure that when engineering students, they would work in certain projects, they would be in a very good position to appreciate the use of this big data analytics. And this is one of the case studies that I always speak to people when I meet in different such gatherings. So I think these tools, Tableau, Azure, Hadoop, even if you are a mechanical engineer, I feel that there is a need to get trained on these tools to be employable. So this is a high level architecture. See, whether you are in industrial area, healthcare, consumer, or any domain, every device would generate a lot of data, and then this data is given or is pushed to the cloud through communication gateways. Then this data is saved on clouds. You have Amazon Web Servers, Google Cloud, or any other clouds. Then we have a data analytics platform, using Python, R, or any other language, which processes this big data, because this data is, example, pump. So the pump, so in pump, 3 parameters are monitored predominantly: the pump pressure, the pump energy consumption, and the water flow going and coming out of the pumps. If you are able to measure these 3 parameters, you can very well diagnose the pump health. And then the last but not the least, as I mentioned, the data visualization applications, which will tell you whether a particular auxiliary is working properly or not. And trust me, pump is just the one auxiliary in the industry. You have chillers, you have heaters, then there are a lot of auxiliaries in dairy industry, farm industry. So all these sensors are mounted on these auxiliaries. There is a lot of data which is getting generated. Then there are software modules which analyzes this data, and then there are monthly, weekly, yearly, and as minutely as daily reports that are getting generated, which are monitored remotely, so as to ensure that overall ecosystem is working efficiently and up to the mark and adhering to the local rules and regulations. As I gave the example of the number, the energy consumption per unit of or per liter of milk produced in a particular dairy industry. And again, forget about industry and automotive domain. We have examples as close as to our home. Now homes have become smart, wherein you have.
Sir, I'm sorry to interrupt, but before you move on to this slide. In the previous slide, you used a word where you said that in case, I think the slide before this, you used a word that in case if in this predictive data analysis and things like that, in case if our students are trained, you said that even though our mechanical engineering students may be learning mechanical engineering, but they do not have a lot of exposure to what is actually going on in the market with respect to these predictive tools. Now, and you mentioned that in case if such what can I say, such type of education is provided to them, then it will be really great for their future.
Yeah.
Is there any mechanism that is in place which we can resort to ensure that they get this kind of exposure?
Yeah. So honestly speaking, lot of government institutes like CDAC is there. They have these courses on big data analytics. Even the new courses like Byju's is there, Coursera is there. All would have these big data analytics courses are there. In fact, even a very good institution like I2IT, Indian Institute of Information Technology, Bangalore, they offer data analytics course as as for as low as rupees 10,000. So I think it is just reaching out to the right platform and having that rigor to do these courses. It is amply available in different platforms. Yeah.
Yes, thank you so much, sir.
So then again, smart home. So forget about industry and automotive sector and other iron and steel industry. Even our homes are getting smart nowadays, and there lies a tremendous potential in these areas. We already have fire alarm systems in most of our homes, security access systems where we have intelligent camera to do the surveillance, and now uh, as a user, we already, our algorithms, camera algorithms are have become so smart that it recognizes the user. So someone have pressed the door. First, you were only able to see who was, the certain person is there. But now with the user recognition, that smart app is able to tell actually whether that if that person is in the database, it can able to tell that okay, maid has come, okay, your car cleaner has come, okay, your maintenance guy has come. So the applications are becoming smarter and smarter because of deep learning and because of artificial intelligence. And even if I talk about the climate control, so today I can come to home and I can say, hey Alexa, please turn on the AC, and I need not to tell Alexa that my comfort zone is 26 degrees or 25 degrees. If I have defined to Alexa at the time of configuration that Alexa, my climate control comfortableness is 25 degrees. So when I come to home and I say, Alexa, start on the AC, it is smart enough to, put the temperature at 25 degrees Celsius because that has been already told. Then infotainment systems, advertisements. So if, now the systems have become so smart that if they know that I like to watch football, then there is a likelihood that when I am seeing any web content, I would get advertisements which are related to say football or newspapers. So these systems are becoming smart. Whether it is your home, whether it is your web, everything is getting smarter. And I think since this is across domains, I think the exposure to such smart technology is the need of the hour, and our engineers are typically not very exposed to such smart technology engineering. So again, now I have just I'll just give a summary of what have we covered in the first session. So We just covered about what are the problem in today's engineers, what are the potential solutions. Then I talked about what are the upcoming engineering opportunities for the engineering students. Then I talked about the major trends that I as a person is seeing in the engineering world. Then of course everyone is talking about the electric cars, so I discussed about that. And of course again I talked about the big data and the data analytics and the smart portfolio. So this is the first phase of my discussion. So I would like to take a pause for a couple of minutes, and if anyone have anything to share, any queries or any generic discussion, I'm open to that. Maybe in say 2 5 minutes, we can then move on to the next topic. Or if there is any feedback as to I'm going too fast, too slow, or I'm talking, which is maybe not relevant, I'm open to that also. But let's come to a same page as to whatever we've discussed, and let's move on to the next topics.
Participants are requested to, to share their feedback. If you are not comfortable sharing your feedback on mic, you can always write it in the chat box, and I can read it out.
Okay, if no one has any queries, suggestions, I'll move to the next topic, that is engineering services. It's a matter of fact that many of the engineers post their engineering, they typically work in IT industry. I don't want to generalize this statement, but yeah, you will see that most of mechanical engineers, electrical, IT, computer science, they generally end up working in IT services. But what point I want to bring onto the table is there lies a lot of potential in engineering services as well. And if people have a very core domain or knowledge of engineering services, trust me, they would, they get paid very smartly. Is the good engineers that we that we hire from the market, from the good engineering colleges, trust me, even a fresher engineer would end up having a package of around 6 to 7 lakhs per annum, which is I feel is double the industry benchmark of around 3.5 lakhs as a entry level engineer. So I think if efforts are put by the engineer during his 4 year stint to hone the knowledge of engineering services, I think the future can be bright. And there are not many good engineers in the engineering services domain. And when I talk of engineering services domain, I typically mean people who work in this embedded system domain, because embedded system domain, which consists of hardware and software both, is quite different. It's a different ball game than a IT engineering. Nowhere I'm trying to say that engineering services is superior than IT services. Neither is the intent to say that people should go for engineering services. But if at all, I feel that there is no awareness in the engineering students, regarding these services. That's the whole reason, they go by the typical path that, once the likes of Accentures, TCS, Infosys, Tech Mahindra, they come, people are happy to join this organization, go to on-site, live in some geography for 2 3 years, come back to India. And then after coming back to India, they feel that, oh, I'm maybe doing the same kind of work which my peers is doing, and I'm not doing anything different in my life. And then that frustration level builds up, and then that's a very difficult situation to be in. And yeah, so as opposed to engineering services, I'll say that in engineering services, yeah, there are on-site opportunities, no doubts about it. But it's a very interesting domain. I mean, people would not get bored even after working 10 years, 5 years, whatever suitable to them before switching to another organization. So I think the lack of awareness is what hindering the people to go into these services. And when I talk of engineering services, what is happening in the industry, that I want to highlight in this particular session. So with this, I would like to go to the topic of engineering services, what they really are, and a very high level overview of that. So people would have always this question that when I join, if I join Bajaj, if I join this two-wheeler company TVS, what kind of work would I be actually end up doing it? So yeah, so two-wheel engineering is a very broad topic. Trust me. I mean, these are the areas where a typical engineer works in a two-wheeler or industry. And trust me, it's a very interesting area. I mean, you have infotainment and cluster wherein your all human machine interface is there. This no more a case where a vehicle is just showcasing you speed, how much fuel is in the tank, and how much kilometers it has run. There is lot of information now these next generation vehicles is going to throw at you. They are even going to tell you that at what fuel efficiency you are driving the vehicle, after how many kilometers your vehicle would run out of fuel. It will tell you, your Google Maps will be right in front of your instrument cluster. Last but not the least, if some of your if your say suspension is damaged, that alarm would come on your HMI, that your suspension is not working properly. You immediately that alarm would come. So the vehicles are going to be very smart. The infotainment systems, you will be able to play your music, and everything while riding, just by swipe or hand gestures. So in this way, or just through your eyes, you will be able to control, whether you want to forward to some other music, and all those things are going to come. Trust me, working in this industry, I know for sure what kind of engineering evolution is in place for the next 2-3 years. Then you have electronic mirror. Electronic mirror is no more would be a case that every time you sit on a bike, you have to manually adjust your mirrors. By push of a button or through your mobile app, you would be able to, place your mirrors in a position which gives you the most efficient riding comfort. Lighting, it's no more a case that you are going and you are then pressing upper dipper. The sensors on your bike would be smart enough to sense how much powerful light would be required for optimal riding comfort and safety. So those things would be coming up. Battery management systems, two wheelers are also now moving to electric, so battery management systems would play a vital role because it is the heart of the system. Engine management system, so if you are running out of oil, so of course you get an oil indicator, but on a weekly on your mobile app you will be able to see that, okay, in the next coming say 15 days your oil, the way your oil quality is degrading, you will require to change your oil. So you can do a lot of planning before your vehicle conditions is going out of the place. Emissions, now because of the various Bharat 6 vehicle norms, emissions have become a very important criteria. Now in COVID times, everyone have understood the importance of environment. So the emissions you can actually see on your app, how much CO2 emission is happening from your vehicle. It will tell you, okay, whether where you, or it can give you even the locations or the mechanics which are registered with the your vehicle, where you can fix, you will be able to fix this problem. Advanced driver assistance, no more would be the case that accidents would be a commonplace. With the new sensors that are getting fitted into the vehicle, if someone is going to dash you from the sideways, maybe around just before the collision, the vehicle would be able to give alarms to the driver saying that there is a possibility for him to take corrective actions. So you understand the kind of technology that is going into a two-wheeler. I forget about the four-wheeler. That is a I'll say 4 hour topic in itself about the kind of technology that is getting implemented into a vehicle, and the same kind of technology is getting implemented in various industries as well. You talk of healthcare, you talk of energy utilities. In healthcare, we are already seeing that the kind of sophisticated electronic devices. Now you have Apple Watch. We can give you a fault detection, which can tell you, if you have a, unrhythmic heart rates. So whole lot of things can be told by your smart watch. The same kind of features are coming on to the vehicles. So the overall intention here is to just to tell the kind of potential that is there in the engineering services. Then again, I will say the automotive engineering or the overall engineering. I mean, what has been, and I'm pretty sure these things are not taught in a typical engineering environment. And I think there is a need from the teachers to pass on this message, to pass on these offerings, to pass on what kind of work is going on in engineering services or in the technology domain, which would be very relevant or would be a business as usual case in the coming 3-4 years. So we have embedded softwares where are, control softwares, then software unit testing. All these things are being done by a typical engineer. If you talk of hardware, the board design, the embedded coding which is compatible with the particular hardware, the kind of components that goes into the hardware, are they the optimum hardware, are the layout of the overall PCB is optimum, then the vehicle harness design, all the electrical wiring that goes into vehicle, the design of that. So as I told in my lecture, previous discussion, is it is no more a game of just engineering. It is a amalgamation of engineering and design. When you put these two things into one bucket, that is where the innovation would come for the next generation technology. The marriage of engineering with the design, and that's what we have been doing as a company. That's what we have been doing, and as a technology enthusiast, that is what I have learned in the last 2-3 years in this industry. Of course, the validation, ensuring that your product is working for a longer time as per the customer's expectation. So here again, again to give a on ground example. Actually, I was, talking about this product development for one of my customers. So the customer was very clear that, see, Rohan, I want this particular product. I will say surround view system we were developing for a customer. So surround view system is when you are driving a car, that surround view system would be into your infotainment system, where this radio and all these, nowadays you get displays on the car, right? These displays where that run on Google Auto and Apple CarPlay. So this surround view system can give a driver a holistic view of front end of the car, back end of the car while parking, and the sideways, while driving, so that is comfortable driving and he is less accident prone. So my customer told me that, Rohan, the material that would go in building this particular product, that the component cost, which is called as BOM cost, which is bill of material cost, should not go more than $100, right? And what my engineers, they have done with whatever components they had selected for this particular product, the cost was going around $170. So as a salesperson or as a business development guy, I had this challenge to convince customer that $100 is not possible. $170 would be the bill of material cost for this particular product. And since the customer was from APAC region, he was like, no, Rohan, my customer, we have done the analysis. The customer would not buy this product if it goes beyond $100 pricing. So I should be able to roll out this product in the market for $100, which is around 7,000 rupees. So then that's where, our engineers were only considering the technology part of it, not the design part of it. And then I called in the designers from my team. Then we set up a war room where both designers and my engineers, they sat, then they found out that what they have done is over engineering. Like if a component B, which is like over engineered for this requirement, it is not required. Even component A can suffice the requirement. So, and that input comes from designers, because designers understand the creativity, they understand the layouts, they understand the concept of product development. So in this way, we were able to bring down the BOM cost, forget about $100 to $90. And the customer was happy and we got the deal. And now you can see these systems coming in the upcoming vehicle program of a customer. So from 2022, the customer's vehicle would have these surround view systems as a default in their base model. So in this way, I think this kind of thinking is required. I mean, design engineering is required in addition to engineering knowledge that the today's engineering students have. Then again, lighting is such a, I'll say, a very basic area, but understand, even for designing lighting for two-wheeler and four-wheeler, there is lot of engineering and design services that go into the picture. It starts from design. What are the schematics? Because the first thing when a particular individual looks at the car or two-wheeler is the light, when he decides to buy a vehicle, or one of the features that he looks is to lights, because lights enhances the look of the overall vehicle. So the schematics, again I said, the generation of BOM, what would be the per unit cost of that light, the software design, there is a lot of software that goes into the lighting systems. Then the requirement analysis, what end customer want, going and asking people what would be your preferences in the upcoming vehicles with regards to the lighting systems. Then of course the testing efforts, the integration efforts, because see, creating these systems on computer, designing it on computer, but creating that model and implementing on actual vehicle before rolling out to the market is a big task in itself. So again, the intention is to just highlight to the entire people that even a small thing like lighting is, a lot of sophistication that goes into that. So again, this is a very, again, this is a system and software engineering. So this is the kind of engineering effort that goes before a product is rolled out into the market. So I will not go into details. These are very technical slides, but I thought it's important to tell that what kind of efforts goes into designing a vehicle, right from operational level, requirements, functional engineering, subsystems engineering. So and once people aware know that these are the engineering opportunities lying in the market, I'm pretty sure that people would want to learn these things, because these are very niche areas which is not particularly people are exposed to in their general engineering courses. Even in testing of even in cars, even seating systems, a basic thing like seating, it goes into a lot of testing, because we have to ensure, nowadays many of these car companies come out with the advertisement that ours is the safest car rated by the NCAP. We are 4.5 rated, we are 4 rated. So Nexon comes up with the advertisement in the market saying that we are the safest car in India. So on what basis they are saying that? As an engineer, I always had this doubt, even during my engineering days, that X company is claiming that I am the safest car in India. On what basis? What are the parameters on which they are saying that? So then I understood, working across industry, that even for seating, lot of simulation, lot of testing goes. Actually, the actual vehicle is crashed against the walls in various environments, against the truck. So all possible crash scenarios are done in a lab environment, and how your seating system ensures that the driver, is not getting hurt. So such simulations are done, and this is not only for seating. Even for your AC systems, they have different kind of testings which is in place, which ensures that the AC is working fine in all the working environments. Because in home, your home AC is under static condition. So the testing is not that stringent, but when it is a AC in car, it will go under various environment. When you are driving in rainy season, when you are driving in snow, when you are driving in North India, when you are driving in South India, the conditions would be volatile different. So how your system performs in this volatilities is the true test of that particular system. And trust me, these are very interesting areas, and industry is ready to pay heavily. I will double or triple the starting pay packages. People who are in these areas, and I think what really requires is to just to give a overview, or the awareness needs to be generated among the engineering students. Then again, design engineering. So again, design engineering, as I said, is not a very simple topic. In design engineering also, so design engineering means when you are sitting in a car or when you go to an industry, your human machine interface would have different icons, different screens, even in your mobile phones. Your iOS system and your Google, your Android system would have different user interfaces. The same app which is used in Apple would be different when it is used in say Android. So what is the difference? The difference is of design engineering. The design engineers who are working in Apple ecosystem, they have created a different architecture than the people who are working on Android systems. Why Apple is claiming that, oh, we are safe. When you buy an Apple phone, you did not to worry about data security. So as an engineer, we should be able to appreciate that there is a lot of design engineering efforts that have gone into while designing Apple systems. So again, as a techno-commercial guy, I would like to give the various stages of design engineering. Again, it starts for specification documents for the complete feature list. I mean, what kind of icons you want. Then again, the security system. There are different protocols are there. So in this way, the different specifications are defined while for any app development. I'm here specifically talking about the software development that goes for various industries, automotive, human machine interface. Then detailed testing strategy is defined, that in what environments we are going to test this particular application. Then there are different interfaces. I mean, for communication, having because now we are talking of connectivity era. What is smart factories? Wherein one machine is communicating to another machine. So multiple auxiliaries, they are communicating with each other so as to ensure that industry is getting efficient. Like in Amul, I'll give a classic example in Amul. Why Amul was defaulting on energy consumption per unit of energy consumption per liter of milk produced? Because all the auxiliaries were working independently of each other. So for example, if particular application requires 100 liters of water, and if the 100 liters of water was supplied to that particular unit, that unit was not communicating to the pumping system that my requirement is met, so you please switch off. That was not happening. Every other auxiliary was working independently. But when we implanted smart sensors, the connectivity angle was brought into the picture. So now a end application which required 100 liters of water, once that water was filled or that requirement was met of the process, it was able to communicate to the pump that my requirement is made, you please switch off. The pump will get switch off. If pump is getting switch off, then that communication went to the motor controller unit. That pump has switched off. Now control motor unit will also get switched off automatically. So you appreciate that in the connectivity era, the connectivity angle would bring in efficiencies and the much required communication. So in this way, the another strategy would be to define the communication protocol between different machines. Then supplier coordination. In today's world, I cannot only rely on one supplier. A company would have different suppliers who are providing their services and goods to a particular organization. So then the proper coordination of it. If I am say, so for example, Amul is, bringing 100 packaging material, 100 units of packaging material from supplier A. So, if supplier A defaults and he is able to only provide 80 packets, then from where my rest 20 would come? So, all this supplier coordination and supplier roadmap definition is done by the design engineers. Then last but not the least, the testing and other things. So in this way, design engineering is also one of the key areas which is getting prominence in today's world. And I'm pretty sure if people takes up this engineering, or if they are able to imbibe the design engineering concepts in addition to their base engineering degree, I think they would be much more employable, as is the case. Then again, HMI and UX engineering.
Sir, sorry to,
Yeah.
is it okay to interrupt? Or?
Yeah, sure. Please.
You mentioned that the designing engineering concepts should be included in the curriculum. When you say that they should be included in the curriculum, do you mean that some practical aspects of it should be included, or is I am not from mechanical engineering, so I would like to understand that what is the actual case? Is that the theoretical syllabus has it, but we need to introduce the practical aspects, or
So honestly speaking, design engineering is not something that can be taught through any virtual courses, or it can be taught in a classroom environment. I think here is the need for the institution to have a collaboration with different industries, and as a final year internship or a final year live project module, these people should be encouraged. Those who select this design engineering module as a say add-on subject, and they should be encouraged to visit the industries, because some of the things can only be learned in industries, not in the typical four walls environment in the engineering institutes. So I think that would be really helpful. I myself, in my last year of my engineering, I did my internship in Koradi Power Station, and trust me, all these HMI and human machine interface, all these things I actually learned when I visited the power plant. Uh, Honestly speaking, many of the things which I have learned in my engineering, but when I went to the power plant, even that particular auxiliary was in front of me, I was not able to relate as what is this auxiliary. I am not able to understand. Then that person, trainer, told me that this is the X auxiliary that you have learned in your college. Then I was able to appreciate that these human machine interfaces are very much in use in all these system and process industries. So yeah, I mean, going to the field, doing these internships would definitely help to understand the finer concepts of design engineering.
no, sir? That makes me even more curious about another thing that I have in my mind. That in case if suppose we start approaching the industries for our students,
Yeah.
do you think that the industries will appreciate this, and what is the probability that they will consider that they will provide some hands-on experience to our students in the industry for say 1 month, 2 months, or if not 2 months, then 6 months or something like that? Like what would be the
Yeah, so honestly speaking, my perception was that only, that why industry would like to, give or give their time to person like me who doesn't know engineering, who is just a fresh graduate or just into his final year. But trust me, the perception in industry is not like that. People in industry working in the same domain and the same thing continuously, they have lost that innovative thinking angle, and the leaders in the industry now understand that these fresh bloods or these interns who actually come to these industries carry that zeal and enthusiasm and innovative thinking that is very much required to take the industry to the next level. So that openness is very much there in the industry. And if a particular person is enthusiastic, he's creative, he's having that hunger for knowledge, and if he is able to portray that during the interaction, and if these industrial trainers or the industrial coordinators in the organization are able to give the right set of message to the industrial contacts, I'm pretty sure this would be open to, open to bring the students for 6 months or 3 months of internship. Even in my organization, we have a internship program wherein in fact, we proactively invite people from good engineering colleges to come to us and challenge us that what we are doing wrong in the technology development. So this is the case. So it's other way around. People in industry are wanting to have good people rather than people in education sector wanting to go to industry for internships. So yeah.
Okay, there is one more question, sir.
Yeah.
And the question is from Kanchan Ingole ma'am.
Yeah.
She wants to ask, sir, what about the job opportunities in design technologies, particularly in India?
Particularly, yeah. So job opportunities in design engineering is very well there, and I would say in design engineering predominantly it is coming from your home appliances, automotive sector.
Okay, sir.
Yeah, so predominantly it is in automotive and home appliances sector. So recently the Whirlpool Center in Pune itself, near Pune. So they wanted to come up with new products in the COVID era, and they launched a new washing machine, which they claim that they can wipe off the COVID-19 bacteria. So I was in close contact with these guys because we ourselves provide this service of design and engineering services for product development of washing machine. So of course we didn't got the business, but trust me, they hired around 50 engineers from top engineering colleges from Pune, and these people were responsible for coming out with a solution, innovative solution for this washing machine. And they were all either design engineers or electronics engineers from these colleges in Pune and near areas. So yeah, so there are ample job opportunities, predominantly in this home appliances sector. So companies like LG, Samsung. Now Samsung have decided that all their television sets would be manufactured from India. So definitely their R&D center. All these major companies, LG, Samsung. Then you talk of Panasonic, and you talk of other companies, they would have their R&D centers, and then these R&D centers typically hire these design and electrical engineers. Even
Uh,
even tier one companies, because automotive companies doesn't make all these components by themselves. They rely on tier ones, like for Bajaj, most of their components comes from companies like Varroc, Endurance, which are the suppliers for other automotive companies as well. So they have a R&D center, and this R&D center, they hire for design and electrical engineers. Another area is medical industry. So medical device industry. You know that this Omron company, for example, now they are producing pulse oximeters, heartbeat monitor, this what blood pressure monitors. So healthcare industry, lot of electronics, is involved now. So these people also hire these design engineers. Another good industry would be these OTT players. This Sony Live, Z5, all Balaji is there. So for creating their mobile apps, they heavily recruit design engineers. For my knowledge, the Sony Live, which is based out of Pune, they have hired, or they have at least a team of 500 design engineers for their Sony Live app. So you can just appreciate the kind of opportunities the design engineers have in today's world. Yeah.
Sir, there is one more question,
Yeah.
and the question is from Harish Sayankar, sir.
Yeah.
He wants to ask, is there any plan to launch virtual reality car showroom by Tata
Yeah.
Technologies in India?
Yeah. So virtual technology is already there. Recently, for one of the rail customers, where I was involved in bagging that deal, we have won the deal for digitally creating the railway experience. I mean, once in that metro project, once a user or a customer enters the railway, what would be his experience during a travel time of, say, from station A to station B? So typically, that is called as a digital mock-up. So customer said in this COVID-19 era, you give us all digital solution. So my team, which is based out of Mumbai, have created that virtual reality demo for the customer, and we are going to supply 10 sets of laptops and the virtual reality headsets. The headsets are manufactured by HTC. These are called as HTC Vive headsets, and I'm very happy and indeed a privilege to tell you that that digital mock-up would be inaugurated by Mr. Narendra Modi virtually. So we are going to my own company is going to provide that laptop and this headset gear to Narendra Modi, and Narendra Modi sitting in Delhi would be able to experience that metro rail if it for a journey from point A to point B. So all the seating systems, air conditioning system, passenger movement, alarms, means they say that this station is coming in 5 minutes. All these things Narendra Modi ji would be able to experience through VR, and we are able to we are creating that content that would be showcased in VR, and even for Tata Motors, when they went to now when they are trying to sell cars on an online channel, people will be able to experience the car experience virtually. So in this way, yeah, the things are rolling.
That's, I suppose that's really great, sir. Congratulations to you that you were able to, it must be a matter of pride for you as well as for your company, both, right?
Yeah. So we have won two projects. So one would be inaugurated by Mr. Narendra Modi ji, and another would be Yogi Adityanath ji. Both the projects would be inaugurated. One would be by Narendra Modi and Adityanath ji, and that both through virtual reality, using augmented reality, virtual reality. Yeah. So.
So I suppose those were the questions, sir, that have been answered. Now, if you wish, we can move on to the next slide.
Okay. Yeah. Again, I mean, again, this design, no, as I told you, human-machine interface and user experience. There is a lot of, processes and steps in design and development. So in design, there is a lot of research and benchmarking has to be done. Whether my product, how, see, if a company A is doing a design in their mobile app, there is always a research and benchmarking as how it should be different from, say, my competitor, how it should look upgraded from my previous mobile app, how it should be compelling to the youth, right? If I talk of OTT, who are the major users of OTT? People from 20 years to 40 years of age. So how that can look very attractive to this age group, then I have to create very, these are all interaction, OTT and mobile app. So how I am able to create that interactive design? Then video design is nothing but if I use my AR and VR, this VR headset, then how I can give that experience that as if the product is in front of him. And of course, the content development, because my product should look actual like a real project. Then in the development phase, there is a lot of simulation, porting, and testing that is involved. And these are very interesting areas. And I'm pretty sure that once people appreciate the fun angle in HMI and UX engineering, they would be really looking forward to work in these areas. So typically, as I shown you, HMI designs, 2D, 3D, then AR experience. This is augmented reality experience. So you would know that Kia has come up with a car, Seltos, which has a heads-up display. So you no more have to look into the instrument cluster regarding your speed and other thing. When you are driving on your mirror, when you are driving in mirror only, it will show you the speed and other parameters. So that is nothing but the augmented reality experience. So all those things are very next generation things, and I myself are involved in product development and selling such services. And trust me, it gives an immense pleasure, and it's a very fun thing to work in these areas. And I'm pretty sure that would be the case with other people once they decide to work in these areas. So now, we have just completed this, so I have not covered here typical engineering opportunities. These are very niche, and out of 100 engineers passing out, maybe 15-20% would be interested in that. So rather than typically covering this electrical, mechanical, computer science, IT engineering, and the other topics which are common, I thought to give a little niche taste to it, and I hope that I was able to achieve what I wanted to by covering this
Very
presentation.
much, sir. Very much. However, the way, the kind of future that you have already mentioned we will have in the time to come, we may expect that these niche areas which you have mentioned, would, in these niche areas also more than 50 to 20% of people will automatically be, employed, because there will be so many opportunities there, is what I suppose now.
Yeah, definitely. Yeah, definitely. That is the trend that we are seeing. That people are now bored, or they are not interested in having a typical opportunities that they hunt for. And since these areas give that pulse of excitement, something new, something different, so people are more than open to now work in these areas. And at first our company had a lot of problem in recruiting engineers, because these were very niche areas, but now these areas are being taught in various engineering colleges, or people are proactively taking these skills on their own, and actually these have eased our burden, and now we can see that many people we are able to recruit without going into hassles of doing a lot of research and getting the relevant profiles. So I foresee that these areas would expand and would be significant percentage of the career opportunities for the upcoming engineers. Now, I would like to give very high level case studies as to where these AR, VR, next gen technologies are getting implemented, so as to give you a sense of how it is able to resolve the problem of the end customer. So first, I will like to give an example of a bag handling system. So if I talk of current system, it is a very mechanical system. You put on a bag on a conveyor system. The conveyor system, scans, and then there are different, pre-decided directions through which it goes, like bag driver, divider device, conveyor motor drives, and then it comes to the end bag carts and then given to a particular passenger. Now imagine a situation where a belt has malfunctioned. It has stopped working abruptly. Now it takes some time for a field engineer to understand that which belt has defaulted. Then so it takes a lot of time to for him to inform the maintenance team as to what have defaulted. And the end result is the customer is kept waiting for his package. Then a technical will figure out an alternate belt which can be replaced, or an alternate path which might they have kept into the mind if that particular belt have defaulted. So it results in delayed schedules, rapid baggage buildup and unhappy passengers. And trust me, airline or in this airline aviation industry, the last thing they want is an unhappy passenger. So now imagine a situation that you have enabled a IoT, Internet of Things enabled solution in this bag handling system, where you have integrated sensors which the sensors are monitoring different data. Then there is a gateway which is able to give this feed this data to the different servers, and then going to the particular maintenance department on their mobile application or a computer device. And the parameters could be the status, whether it is running, idle, which location particular brake is working, and of course a unique ID for that particular belt. So in this scenario, if a belt has malfunctioned, the sensor would send an alert to the particular field manager with a precise fault, fault notification also, whether there is some problem in the mechanical system or electrical systems, or what is exactly is the fault. So here, what would be the outcome? That it would have no impact on the pileup, and it would quick problem resolution, which would enhance the end customer experience. And that's what a airline or a aviation or a hospitality industry want. A good customer means they will get a repeated business. Repeated business means larger revenues. Larger revenues would mean their business goal is getting achieved. So this is a very basic but a very important example of how IoT enabled devices, smart technology is helping industry to solve their day-to-day problems. And not only the running problem, but predictive maintenance will also be achieved through IoT. Means by vibration analysis, heating analysis, it will anyways tell the maintenance officer that see the vibrations are happening, and we predict that in the next couple of days this device might default. So in that scenario, during the downtime, the maintenance manager can replace the belt and take corrective action so that the default this belt is not getting default and it is not hampering the end user experience. So in this way, IoT is solving our day-to-day problems. We as a passenger, we find it very easy that when we come out of the flight, when we collect the bag, we don't appreciate the kind of operations that go back-end operations that goes into it. And I think with this example now, I think most of us can really appreciate the next time you go on a conveyor belt and you pick up your bag. I hope at least you will appreciate that, you will appreciate the technology that have helped you to get your bag on time. So this is one of the examples: cost optimization, great passenger experience, preventive and proactive maintenance, and you have a single instance of truth, which is giving you a proper data. Because see, why single instant of truth is mentioned here? Because technician A would have another analysis. He will say, oh, electrical systems have defaulted. Your technician B might say, oh, your mechanical systems have defaulted. Maybe technician C would come with some another, analysis of the problem. But here you have a very one single truth of problem, and you have a very good understanding of what have actually happened on ground. So another example is, these are the some of the technologies that we as a company are, developing, and these are very interesting case studies. That's the whole reason I thought to bring one to the table. Now we are working on a image processing application wherein a electric vehicle would, when the battery charge is down, they would automatically through Google Map interface would be able to detect where the charging pad is nearby, and that would be a wireless charging pad. Then that vehicle would go into that hub, this recharging hub. Once it entered a recharge hub, it would automatically detect where exactly is the location of the charging pad, and the vehicle would, get parked over that wireless charging pad. Then the charging will start, and that interface will tell how much time it will take to charge the battery, so that in that meantime you can go to nearby mall, or it can tell you what nearby restaurants, mall, or any other recreational activities can be done. So while the time battery is charging, that interface is so smart that it will pick up data from Google Maps and will tell you that hey, it will take 52 minutes to charge the battery. There is a mall which is say 200 meters from here, and then there is a Burger King in the second floor of that mall, and you can go and come back. So this is the level of sophistication that we are trying to bring in today's world. And I think today what seems to be a use case would be a the realities of our life, and trust me, it is going to happen in 2025. At least with the car program that we are developing, this would be the truth. Then, typically, again, since I've worked extensively in the industrial manufacturing processes, I always like to give the example of a manufacturing process. So imagine, there is a manufacturing process. We have sensors data, implanted on the machines. Then there is a artificial intelligence engine that is analyzing the data that is getting thrown up by these machines. the AI engines detects that there is an anomalous data, so some corrective action needs to be taken, and then it suggests the end user, the maintenance head, that these are the some of the anomalous data that we have received, and it's high time that you do some corrective action on those machines. In the downtime, the maintenance manager goes, does the corrective action on the probable things that may have gone wrong, and then the entire manufacturing process have not got disturbed, and then there are no breakdowns means there is a continuous functioning and enabling the business revenues for an organization. So these are the use cases which are now actually in place for smart factories and the sophisticated plants, and again gives me a good again I feel absolutely happy that we have in fact we have implemented such solution for one of the company based out of Gujarat, and they are predominantly into the car manufacturing domain. So again, machine monitoring and failure prediction. Again, here I would like to give the example of pump, or rather motor, wherein we have implemented smart sensors on motor. All the voltage parameters are getting tracked, the RPM, the current that is consumed by the motor, the vibrations, the sound, and everything is getting all by smart sensors. The data is given the artificial intelligence based system. That system is able to tell the these are industry terms. MTTF, mean time to fail. Mean time to fail is that what is the average time that if corrective action is not taken, the particular device will fail, and data pattern on each parameter and gross variation. So wherever the variations are going above a critical limit, there is a time to take the corrective actions. So now you can really I will say appreciate the implementation of smart technology into the industrial world, how it is helping the industry to work efficiently. Then again, for a for one of the automotive client, we have implemented this, and trust me, these use cases, if we are able to tell to the engineering students, I think their learning curve would be taken to some another level, and they would be able to relate the learning with the things that are happening on ground. And I think this is the way the future learning needs to be undertaken. Again, here the different wave patterns is analyzed by the AI engine, and wherever the abnormal patterns have been analyzed, it gives the proactive signals to the this maintenance head, and it reducing the device downtime and enables predictive maintenance. So yeah. So this is the overview of the case studies that I have taken. We started with a very basic case studies for baggage handling systems. Then we moved on to an interesting example in electric part detection. Then some of the industries examples. So yeah. So if anyone have any, I think in the interest of time, I would like to don't like to take any break or ask for any question. I'll just move on to the next topic, wherein the key engineering areas or the key areas where the present engineers can look out for work. So these are the few areas where I feel that people can make a great career, or I'll even make another word, can make a fantastic career in the coming years. So again, AI, robotics, predictive analytics is one of the areas. Predictive maintenance, then connected components, because people in industry like dairy and all iron and steel, they have engineers. We have typical mechanical background or instrumentation background, but these people don't really understand the data analytics and the IoT parts. And if they are having such profiles of IoT and people knowing the data analytics and the use cases, I think there are a lot of opportunities, not only in India, trust me, outside India as well. Countries, if I talk of Germany, they have a lot of manufacturing units in automotive and allied domains. Every company, every country would have power plants for meeting the power demands. Another great country where these, engineers are getting demand is Middle East, because in Middle East there are a lot of oil rigs and oil and gas, rigs are there, and these technologies have a very good return on investment if implemented in oil and gas sectors, wherein not necessary that people can go and work in these fields onshore. Even in the capacity of consultants there is a lot of opportunities. And yeah, so oil and gas field is, trust me, the sky is the limit for such engineers. Then, of course, automated inspection. Like I said, in the dairy industry, every packet of milk that is produced and shipped goes into a lot of inspection, because it's a very critical, critical product. Even some problem in one of the milk packets can hamper the brand image in front of the customer, and there are a lot of regulatory and legal issues that a company gets entangled into. So in this automated inspection, all these, say bacteria content or any anomalies if are there, there are smart sensors who, inspect these food packets. And if an engineer understands signals the process, so I think he is much more employable in such application. Process optimization, as I told you, that HMIs and entire processes which are there. I give you an example of the functioning of pump in a dairy industry. So how implementing a smart sensor actually helped in connecting the auxiliaries and bringing the process optimization. Again, it gives me a great great pride to tell you that in the process optimization assignment which we have undertaken in Amul Dairy, when I was working with PwC, we were able to achieve a process optimization of precisely 21.2 percentage when we implemented the IoT solution, and the return on investment was less than a year. Within 9 months, they were able to recover the money invested in IoT infrastructure. So yeah, that's the kind of returns one can expect in process optimization industry. Augmented reality application, I already give an example of the augmented reality application for the metro projects which would be inaugurated very soon by the prominent people of our country. Autonomous guided vehicles, again, uh, the Mahindra, when I was working, we have worked on a project for autonomous tractor, and now it is in production level, and many farmers are using that autonomous tractor, wherein for plowing the field they cannot, there is no need for a person to drive the tractor. The tractor is intelligent enough to go into autonomous mode and do the plowing part. Then data visualization, as I told you, the data analytics and the reporting that comes from I2 sensors. We need people who understand what data or what report have thrown up, because basis those interpretations only corrective actions can be taken. Plant performance analytics is again, analyzing different data and ensure that the plant is performing as per the required mandate by the particular by the local government. Inventory management, what better time I can say to talk about inventory management when the likes of Flipkarts and Amazon have started their festival sale. Now imagine for serving country like India, the inventory hubs of such companies would be huge. And to ensure a proper inventory management, the only way is to use IoT and the data, so that these people are able to manage these hubs efficiently and effectively. This is again smart logistics. I give the example of Amazon and Flipkart. Again, I would like to talk little more in creative part. So I have touched upon the topic of creative engineering. So definitely, industrial in corporate world, it is known as industrial design. So industrial design is nothing but creative engineering. So industrial design, helps customer to develop enduring brands and products by using design as a differentiator. And industrial design, it helps to give customer insights, it helps in branding, and it helps to create a differentiator. And trust me, the opportunities in industrial design are in various domains. So of course, the transportation, the design of car, the design of car components, the design of right from your steering wheel, doors, lighting, that comes under industrial design. If you feel that you are you know if you feel that your car and your lighting systems, your overall seating arrangements is designed by engineers, then sorry, this is not the case. These are designed by designers who are typically coming from art background, or they have some hybrid course in mechanical engineering. So trust me, that's a very good profession to take up. Then these designers are also involved in designing these consumer products like laptops, water purifiers, fans, and whatnot, the consumer electronics domain. Again, I myself have sold my industrial design capabilities, and have worked in designing like Horlicks and Boost and shampoo bottles. So there also the engineering design have application. And yeah, and user interface, I've told you, like OTT, mobile app, and other human machine interfaces. So this is the application of industrial design, and just a brief background. And yeah, so again, in automotive domain, all these features in a very high end classy Mercedes and BMWs and Audis, these are all done through design engineering. This is not done by typical mechanical electronics engineer, but these are cherry picked resources who have done their engineering and some design courses from Indian Institute of Design, or some in IIT there is a course, in IIT Bombay there is a course for design and tech in design. So these are the people who have worked on such projects, consumer research, use case scenarios, navigation. So see, a Google Map and Apple Map and a Map My India map, the navigation experience is different. Why? Because the navigation design concept is different in a Google Map or in an Apple Map. So that's the differentiator, is there through navigation design. And of course, there is a lot of engineering opportunities for implementation support and visual design. This is the example of digital mockup that I gave for for two projects that we are executing, and where I myself have area of interest. So see, the person who is using that VR, this is just an overview. But when he actually uses the VR, the visuals that in the VR he will see is the visuals that are given in the right hand side. Like he's walking on a platform, then he opened the door of the metro, then he will be able to see all the sitting systems, how is the overall design inside the train. Then if he has to take some coffee in the train, where he would go and what would be the user interface of that coffee vending machine, everything virtually he will be able to see through those virtual reality. So these are the one of the interesting opportunities in the virtual reality domain, VR domain. And of course, design also, because for content that goes into this, digital, this virtual reality, so to create that content also, a lot of digital design engineering is required, wherein concept, then there are GA drawing, then there are designs, CAD diagrams, which goes. So yeah, these are all very interesting areas, and I'm pretty sure that once the engineering students are aware, and if they are able to properly guided, then they would be able and appreciate to work in these fun areas. So I think again, I think if the engineering students have to work in these areas, or if there is some revolution that needs to be bring in the engineering sector, how the people are mentored and guided, I think the overall program that needs to be structured should have the graduate should gain the ability to apply knowledge of math, science, and engineering, because only engineering knowledge would not help. There is a lot of maths and science that should support the engineering. Then, as I told you, they would be able to design and conduct experiments and interpret data in the more efficient way. They should able to design a system, component, or a process that needs the end user requirement. Then, of course, they should be able to function in a multidisciplinary teams, because in a typical organization setup, you would have designers, engineers, MBAs, MTechs, legal, and the other people. So how they are able to function in this multicultural environment? They should able to identify, formulate, and solve engineering problems rather than just focusing on the technology. They should focus on solving engineering problems. Of course, they should understand the professional and ethical responsibility and impact of engineering solutions in a global and social context. I mean, just to put it in a right way, they should understand the legal, not only technical but legal, social, environmental, and other relevant aspects in the product development management cycle. They should able to communicate effectively, because they should know the domain language. And last but not the least, they should be able to use the technical skills and modern engineering tools. The latest tools. They should have exposure to next gen tools for engineering practice. And I think there needs to be a quantifiable output of measuring the outcomes of the programs. I mean, a 4-year engineering program. I sincerely feel that only measuring outcomes in terms of marks is a very crude methodology of understanding or measuring a student's performance. So I think in addition to marks, there needs to be a list of measurable learning outcomes that maybe he have not scored in that particular paper, but might be the case that he have learned from that program. And I think that learning outcome is more important than the marks that a person scores. Maybe, sorry if I'm talking too philosophical, but I think that's the need of the hour. Then there are definitely a list of measurable learning outcomes. A matrix needs to be formed which captures the outcomes on the learning experience rather than marks. Then we definitely need to modify the educational experience that the learning outcomes of an individual are gained. And at the end of the 4 years, he would feel that he should feel valued that I had good outcomes from my engineering program, and I have taken the right decision of going for engineering. No more should be the case that he should end up in an environment wherein even non-engineering graduates are ending up doing the same kind of work what he's doing, so that he's feeling that what outcome I have achieved by doing my engineering. So that kind of feeling he should not gain once he starts working in his professional career. And last but not the least, you should establish a periodic review of program learning outcomes by external, faculties, or maybe an advisory board, or hiring external consultants, or conducting such programs wherein people can give you a third eye view of the performance or the overall review of your learning program. So I think that third eye view is very important, because students, teachers, generally they are involved in typical scenarios entire 4 years, and that third angle view would be very much required to bring the much required change in the system. So with this, I would like to end this, and I'm happy that I was able to cover and finish at dot 5:30. So thank you very much, and indeed a pleasure to be a part of this discussion. Now I leave the forum open for any questions, discussions, and for the end note. Thank you very much. Thank you all.
If anybody has any queries, any doubts, or anything to share, the participants can unmute themselves, and feel free to talk to our resource person. If anybody has any queries, you may ask now.
Or is there any feedback? Is there any, anything you want to share off the record? Nothing maybe related to this topic. I mean, any kind of discussion I'm open to, maybe for another 10 minutes, 10, 15 minutes. Uh, yeah, any formal, yeah, other things, that's fine. But anything under the sun, if you want to discuss, I mean, we can have the discussions.
So I suppose that there aren't any more queries
Yeah.
that people have here.
Yeah.
On behalf of Ballarpur Institute of Technology, sir, I would like to thank you for taking out time from your busy schedule. It was a very rare privilege, to have attended this session, because the kind of examples that you have covered are very relevant for the topic of this faculty development program. Because we are trying to improve the quality of teaching in engineering education here, and I suppose that you have covered almost all the. You did not just cover what is ongoing right now in the engineering world, but you have helped us understand very clearly as to what the future of engineering is in India as well as across the globe, right? And the examples that you have covered, I am really thankful that the examples that you have covered are not from one particular sector. They are across, irrespective of whatever, right from food industry to aviation industry and to any other like agriculture industry. I suppose you have covered examples from almost all the industries wherein we have now a fair idea as to where the individual, where we can see the future of engineering. And accordingly, we would, I suppose that there are so many senior faculty members also here who have attended your session. I suppose that they will be planning accordingly in the time to come, because apart from university curriculum, there are many professors here who would take charge and who are already, who already take charge and who love to mentor their students. Now, Vijay Chaudhary sir has shared his feedback on chat, and he's saying really very superb and focused on design reality and imagination is the only limit. Thanks a lot, sir. Anu Johnson ma'am has shared her feedback. She says, "Thank you, sir. Really informative session."
Thanks everyone for such a kind feedback, and it really now motivates me to improve further, and I definitely, I mean, the whatever overall I find the session to be really interactive, and the kind of discussions or the questions that came from the people were really helped me to understand another dimensions of the learnings that I have gained on ground. And I can only say thank you so much for such a wonderful words. It motivates me further. That's what I can say at this point of time. Thank you.
Sir, it is a matter of pleasure for us to have, to have regional manager of Asia Pacific of Tata Alexa with us, and the kind of information that you have shared has really added value. I mean, I do not have words to express my gratitude for this session. Is all that I would say.
Thank you.
So I would sum it up with thank you very much. Thank you, sir.
Okay. Thanks everyone.
All the faculty members who have attended the session are requested to fill in the feedback form for this session, which will be shared on the WhatsApp group shortly. The feedback form will be open and you can submit it till 11 p.m. tonight, post which it will automatically close. So it's a humble request to fill in the feedback form before that. In case of any queries, you can always contact our coordinator for this faculty development program, Mr. Sunil Kuntawar sir, or you can contact the co-coordinator of this faculty development program, Mr. Ashish Manusure sir. Thank you very much for being with us today. Tomorrow we will resume the session at 12:30 p.m. as usual. You will receive the link for tomorrow's session by tomorrow morning, and we will resume day 7 of this faculty development program tomorrow at 12:30 p.m. as usual. The schedule for next week will be shared tomorrow. And with that, I will conclude today's. I would say that the session is concluded. Thank you very much.